This will be for the con exercise. Interpret change in exponential models with manipulation. All right, ocean sunfish are well known for gaining a lot of weight. The relationship between the elapsed time t in days since the sunfish is born and its mass is modeled by the following function. Complete the following sentence about the rate of change in the mass, round to 2 decimal places. The mass of the sunfish increases by a factor of 9/7 every blank days. Okay, so this is basically asking right here, how often is it multiplied by 9/7? So right here is what we are multiplying by, and we want to equate this to 9/7. Okay, so you want to just ignore the initial value. Okay, you want to just ignore that. And let's do 81 over 49, and that is to the power of t. All right, I just recopied this part, and I'm going to set that equal to 9 over 7. All right, so let me make a little room here. All right, so you just equate these two because you want to see what you're multiplying by each time. And in order to solve this for t, we need the bases to match. Okay, since some of this you can do in your head. Okay, we know that 9 squared. We know that 9 squared will give us 81, and we know that 7 squared will give us 49. All right, so I can replace 81 over 49 with 9 over 7. That whole thing squared. Okay, when you square a fraction, that squared gets applied to both the numerator and denominator. 9 squared is 81. 7 squared is 49. So we're good there. This replaces 81 over 49, and that also is raised to the power of t. Okay, and that's going to equal 9/7. And basically, 9/7 is the same as 9/7 to the first power. Now, when you have something with an exponent raised to another exponent, you just multiply the exponents. So that's going to be 9/7 to the power of 2t. And that equals 9/7 to the first power. Now that the bases match, the 9/7, we can just match up the exponents. And we can say 2t equals 1. Okay, I could do this part off on the side here. 2t equals 1. Solving for t, the opposite of times 2 is divided by 2. You do that to both sides. And t is just 1/2. Final answer. All right, 1/2 right in the box. 1/2 is the number of days. All right, Barney is an ecologist who studies the change in tiger population. The relationship, elapsed time t in decades since he started, is modeled by this function. Complete the following sentence, round to 2 decimal places. The tiger population loses 3/5 of its size every blank decades. Okay, so in order to lose 3/5, what are you multiplying by? Well, basically, whenever you start, your initial value is going to be 100%. All right, 100% in terms of a decimal is equivalent to the number 1. So if you want to lose 3/5, you're going to subtract that from 1. So that's 1 minus 3/5. The reason we're subtracting from 1 is because 1 is the same as 100%. All right, and 1 in terms of common denominator, that's 1 is going to be the same as 5 over 5 minus 3 over 5, which is 2/5. Okay, so if you multiply by 2/5, if you do times 2/5, that makes you lose 3/5. All right. So basically, we want to see how often we're going to be multiplying by 2/5. All right. So just like last time, I'm going to ignore the initial value and just focus on this here. We have 8 over 125, and that is to the power of t. And we want to equate that to what we're going to be multiplying by. That's 2/5. All right, so that's basically what we're solving here. All right, so let's solve this here. We need to change this in terms of 2/5. Okay, how do we get from 2 to 8? Well, we know that 2 to the third equals 8. How do we get from 5 to 125? We know that 5 to the third equals 125. Okay, so 2 to the third, 5 to the third. How about we just do 2/5? 2/5 to the third. Okay, that's the same as 2 to the third over 5 to the third. And that would equal 8 over 125. Okay, so this is equivalent to this fraction. And this whole thing has to be to the power of t. Now we can take the parentheses and make it to the power of t. But just like last time, when you have something with an exponent and you raise that to another exponent, they're just going to get multiplied. So this here is really just to the power of 3t. Okay, so you can rewrite it as such. All right, so I'm just going to write it to the power of 3t. All right, and that's going to equal the 2/5. And 2/5 with no exponent is the same as 2/5 to the first power. All right, so now that we have matching bases, we can match up the exponents. 3t equals 1. And this is t times 3. The opposite of times 3 is divided by 3. The 3's cancel. And t is just 1/3. And that's your final answer. That is how often you are multiplying by 2/5 every 1/3 days or decades, whatever it was. All right, 1/3. All right, some of the write-up you can ignore here. All right, this is about locust population. The relationship between the time t and days since the beginning and the total number is modeled by this function. Complete the sentence about daily percent change in the locust population. All right, so they want to know what percentage is addition to or removed from the locust population. So if t is a number of days, what are we doing here? Well, we can ignore this right here. We just want to see what we are multiplying by each time. So if you go with t equals 0, what are you multiplying by? Well, you plug in a 0 right here. All right, that's going to be 0.7. And that's to the power of 2 times 0. Okay, and that just equals, let me make some room. All right, so that's going to equal, let me see, 0.7. 2 times 0 is just 0, and 0.7 to the 0 is just 1. Now, we want to see each day or every day. So first we did t equals 0. Now let's do the next day. T equals 1. Okay, so we're gonna ignore the initial value because we want to see what we're multiplying by. Plug in a 1. We have 0.7. That's to the power of 2 times 1. We're subbing in 1 in place of t. All right, and 0.7 to the power of 2 is going to be 0.49. So what did we multiply by to get from here to here? Well, let's see. If we did 1 times something equals 0.49. If we did 1 times something equals 0.49. And we wanted to find out what that something is. Well, the opposite of times 1 is divided by 1, and the ones cancel. So that something, or that blank space, is just 0.49 over 1, which is just 0.49. Okay, so to get from 1 to 0.49, we basically just did times 0.49. So what does times 0.49 do? Well, if we did 1 minus 0.49, that's going to equal 0.51. And in terms of a percentage, if you move the decimal over 2 places, that's going to be 51%. All right, so when you multiply by 0.49, you end up losing 51%. All right, so that's your answer right there.